using the top-down approach to network design. So this is the fifth installment of the applying methodology to a design. Using the top-down approach to network design. So after establishing the organizational requirements and documenting the existing network, the designer is ready to design the network solution. This section first discusses the top-down approach to network design. Decision tables and structure designs are described, and the section includes a brief discussion of the types of network design tools that might be used. So the section concludes with a discussion about building a pilot or prototype and the contents of a detailed design document. Let's get started. Top-down approach to network design. So basically, this is based on the OSI layer, okay, or the internet model, okay? So you've got the OSI and the IEEE TCP/IP model, okay? With the OSI layers, we are considering the 7 layers versus the 4 layers of the TCP/IP model, okay? Now, designing a large or even medium-sized network can be a complex project. Procedures have been developed to facilitate the design process by dividing it into smaller, more manageable steps. So identifying the separate steps or tasks ensures a smooth process and reduces potential risks. So a top-down design allows the designer to see the big picture before getting to the details. So top-down design clarifies the design goals and initiate the design from perspective of the required applications. So the top-down approach adapts the physical infrastructure of the needs of the applications. Network devices are chosen only after a thorough requirement analysis. So structured design practices should be integrated with a top-down approach, especially in a very complex networks. So top-down approach started with the application layer downward, okay? While the bottom-up is, of course, the opposite. So in contrast to the top-down design, the network design approach in which the network devices and technologies are selected first is called the bottom-up or connect the dots. So this approach often results in an appropriate network for the required services and is primarily used when a very quick response to the design request is needed. So with bottom-up approach, the risk of having the redesign the network is very high. So guidelines for producing a top-down design includes the following. So thoroughly analyze the customer requirements. Okay, so that's number 1, as always. Customer requirements. Initiate the design from the top of the OSI model, which is the application layer. Okay, so in other words, define the upper OSI layers, application, presentation, and session first. And then define the lower OSI layers, transport, network, data link, and physical layer. The infrastructure, routers, switches, and media that is required. So take note that from the fundamentals of networking, okay, so every device is working on the specific layer of the OSI model. So you have to know what specific device is operating on which layer. So also, you need to gather additional data about the network, protocol behavior, scalability requirements, additional requirements from the customer, and so forth. So that might influence the logical and physical design. Adapt the design to the new data as required. Now, the top-down approach compared to bottom-up approach. Okay, so a top-down approach to design has many benefits. So compared to bottom-up approach, including the following. So you've got incorporating the customer organization requirements, okay, So providing the customer and the designer with a big picture of the desired network. Also, providing a design that is appropriate for both current requirements and future development. So the disadvantage of a top-down approach is that it is more time-consuming than bottom-up approach. Okay? It necessitates a requirement analysis so that the design can be adapted to the identified needs. So a benefit of a bottom-up approach, selecting the devices and technologies, and then moving towards services and applications, is that it allows a quick response to a design request. The major disadvantage of the bottom-up approach is that it can result in an inappropriate design, okay, leading to costly redesign. Top-down example, okay? So consider an example that uses the basics of top-down approach when designing an IP telephony, okay, network solution. So in this example, the customer requires a network that can support IP telephony or the VoIP, okay? So IP telephony permits the use of the same network resources for both data and voice transport, thus reducing the cost of having two separate networks. So to achieve this, the network must support VoIP or voice over IP technology. This first step in the design process is illustrated on this diagram here. All right, so the figure illustrates the addition of IP-based network, which is required to support VoIP. So the network includes IP-enabled routers and other devices not shown in the figure. So IP networks delay is also managed, okay, via the quality of service. So to achieve that, specific QoS or quality of service mechanisms are also implemented in the network. Now, this figure illustrates the addition of call monitoring, okay, and management function. This function was previously overlooked because such functions were traditionally handled by PBX, okay, that is on a separate voice network. During the top-down design, it became clear that this function is necessary. So you could have the Unified Communication Manager is therefore placed inside the network to manage and monitor IP telephone calls. Decision tables in network design. So that is creating a network decision table. Decision tables are used for making systematic decisions when there are multiple solutions or options to a network issue or problem. Decision tables facilitates the selection of the most appropriate option from many possibilities and can be helpful for justifying why a certain solution was chosen. Options are usually selected based on the highest level of compliance with a given requirements. So basic guidelines for creating a network design decision table includes the following. First, determine the network building block about which decisions will be made. So that includes the physical topology, okay? So routing protocols, security implementation, and so on, okay? Step 2, collect possible options for each decision, okay? So be certain to include all options or as many as possible to obtain maximum value from the decision table. So a thorough survey of the existing state of technology and considerable knowledge are needed to include all options. Next would be create a table that includes a possible options of the given requirements. Include the relevant parameters or properties. Next would be match the given requirements with the specific properties of the given options. Select the most appropriate option, the option with the most matches. If all requirements are treated equally, however, if some requirements are considered more important than others, implement a weighing system such as each of the requirement is assigned a weight that is proportional to its importance in decision-making process. So this diagram here is an example of decision table for selecting a routing protocol based on multiple criteria. Okay. Now in this example, several routing protocols are considered, like EIGRP, OSPF, and BGP. So 5 required parameters are listed along with the indication of how well the routing protocols comply with these requirements. So we have some video lectures about these routing protocols. Now, as indicated in the figure, the chosen protocol should include the following properties. First, it should support a large network. Okay, so all protocols here considered meet these requirements. So all of these protocols here are compatible with a large or very large network. All right. Next, it must be enterprise focused rather than internet service provider focused. So BGP was designed to support interconnecting networks for autonomous systems. It is not optimized for use in the enterprise. ISIS is typically deployed in the service provider environments rather than the enterprises. Next would be the support for the variable length subnet mask or VLSM is required. So all the protocols being considered supports VLSM. Okay. Next would be it must be supported on Cisco routers, which is the case for all the protocols being considered. So basically all of this works with Cisco routers. All right. It's just that EIGRP is customized for the Cisco device because EIGRP is a proprietary protocol and that is for Cisco. All right. Next would be network support staff should have a good knowledge of the chosen protocol to enable them to troubleshoot the network. So in this case, the network support staff are knowledgeable about EIGRP, but not about OSPF, okay, BGP, or ISIS. Well, basically, this is an example. All right, this is just an example. And based on the stated requirements, well, EIGRP is the routing protocol of choice in this example. Next would be assessing the scope of the network design process. So what would be the scope of the network design? Is it the entire network? Is it the campus or the WAN? Okay, so you should have identified the scope of your network design. Also, we have here an example of assessing the scope of the network design process based on the OSI layer. Okay, on the application layer, designing voice transport. On the network, basically designing routing and IP addressing. Okay, and on the physical data link, choosing a connection type. So that is based on these 7 layers of the OSI model. Structure design. So the output of the design should be a model of the complete system. Okay, the top-down approach is highly recommended. So rather than focusing on the network components, technologies, or protocols, instead of focus on business goals, technical objectives, and existing and future network applications and services. So structured design focuses on systematic approach, dividing the design task into related, less complex components as follows. So first, identify the applications needed to support the customer requirements. Next would be identify the application's logical connectivity requirements. with a focus on the necessary infrastructure services and network infrastructure. Next would be split the network functionally to develop the network infrastructure and hierarchical requirements. Okay. And then design each of the functional elements separately. Okay. Yet the relation, okay, to other elements should be there. So for example, the network infrastructure and infrastructure services designs are tightly connected. Okay. So they are both bound to the same logical and physical and functional models. Use the top-down approach during all designs. So the figure here is an example of how a network design can be divided into smaller yet related sections using the structured design and practices. Network design tools. So several types of tools can be used to ease the task of designing complex modern network, including the following. Okay, you've got the network modeling tools. Network modeling tools are helpful when a lot of input design information such as customer requirements, network audit, analysis results, and others exists. So network modeling tools enable modeling of both simple and complex networks. So the tools process the information provided and return a proposed configuration, which can be modified. Okay, so using a tool available, okay, and reprocess to add redundant links, support additional sites, and so forth. Okay, so you also have strategic analysis tools. Okay, strategic analysis tools or what-if tools help designers and other people who are working on the design, engineers, technologists, business and marketing professionals, okay, so to develop network and service plans, including detailed technical and business analysis. So these tools attempt to calculate the effects of specific network components through simulated scenario. Okay? You also need decision tables. As discussed, decision tables are manual tools for choosing specific network characteristics from multiple options based on required parameters. All right? So you can also use simulation and verification tools, okay, or services. These tools or services are used to verify the acquired design, so thereby lessening the need for pilot network implementation. Okay, now the figure here illustrates how the initial requirements information is processed with network design tools to produce the network design. Planning and implementation. So if a plan is composed of multiple complex components, then we have to implement each component separately. That is modularization. Okay? Do not implement everything at once. So incremental implementation is also used. So just like in software development, we have incremental. Okay? It reduces troubleshooting in case of failure and reduces the time needed to revert to previous state in case of failure. The design implementation process. So after the design is complete, the design implementation process is executed. So planning a design implementation. So planning and documenting the design implementation is the first step in this process. So the design implementation description should be detailed as possible. The more detailed the design documentation, the less knowledgeable the network engineer must be to implement the design. Okay? So very complex implementation steps usually require that the designer carry out the implementation, whereas other staff, okay, or another company can perform well-documented, detailed implementation steps. Okay? So next would be, implementation must consider the possibility of failure. And a rollback, okay, or rollback plan to revert to the original setup if problem occurs. So list implementation steps and estimated times in a table. Okay, so you've got the detailed implementation guidelines. So if the design is composed of multiple complex implementation steps, so plan to implement each step separately rather than all at once. That's what I'm saying earlier. In case of failure, incremental implementation reduces troubleshooting and reduces the time needed to revert a previous state. So implementation of a network design consists of several phases: install hardware, configure systems, launch into production, and so forth. So each phase consists of several steps, and the documentation for each step should contain the following. Okay, as what I said earlier, description of the steps, reference to the design documents, you've got detailed implementation guidelines, you've got detailed rollback guidelines in case of failure, and estimated time for implementation. Now, the figure here illustrates a sample implementation plan summary. So in the figure, each step of the implementation phase is briefly described with references to the detailed implementation plan for further details. Okay? So the detailed implementation plan section should describe precisely what needs to be accomplished. Okay, so there you've got the date, the description, the implementation details on your document, and of course the monitoring. Now the figure here provides a detailed description of an implementation step. It describes the configuration of EIGRP on 50 routers. Okay, and lists the two major components of the step in the peer router configuration procedure. Okay, now the reference of the design document is useful for retrieving the details about the EIGRP implementation. Building a prototype or a pilot network. So it is often desirable to verify a design before implementation. A design can be tested in an existing or live network. This is so-called pilot, or preferably in a prototype network that does not affect your existing network. So a successful design implementation in either a pilot or prototype network can be used as a proof of concept in preparation for full implementation and can be used as input to the implementation steps. So what are the key points here? Okay, so key points: a pilot test or a pilot network tests and verifies the design before the network is launched or is a subset of the existing network in which the design is tested. Okay, so next would be, a pilot network is normally used when the design is for a completely new network. Pilots can also be used for designs that add to an existing network. Okay? So a prototype network is usually used to verify designs that must be implemented on an existing network infrastructure. So the prototype or pilot implementation can have one of these results. It could be a success or a failure. Success, this result is usually enough to prove the design concepts. Failure, this result is normally used to correct the design. The prototype or pilot phase is then repeated. In the case of small deviations, the design can be corrected and tested in the prototype or pilot network immediately. So the figure here is a sample topology subset of a planned network. The highlighted areas, okay, indicate the parts of the network involved in a redesign. This part of the topology is implemented first in a prototype to verify the design. Documenting the design. So a design document lists the design requirements, documents the existing network and the network design, identifies the proof of concept strategy and results, and details the implementation plan. So the final design document structure should be similar to this diagram here, which includes the following. So you've got introduction. Every design document should include an introduction to present the main reasons leading to the network design or redesign. You also have the design requirements. Also a mandatory part of any design document. This section includes the organization requirements and design goals that must be fulfilled. Existing network infrastructure. This section is required only for a network redesign. The subsection document the results of the existing network characterization steps. So you also have the design. Okay. This section is an essential part of the design document and identifies the design and implementation details. The design details documented will obviously differ depending on the type of design project. So whether it is completely new network, a network redesign, or simply a new service introduction, for example. But they typically include the topology, addressing, and design. Implementation details such as configuration templates and exact configurations of network devices like router switches, okay, are included to ease the implementation process. So you also have the proof of concepts. Okay, this section describes the pilot or prototype network verification test results. You also have the implementation plan. This section provides an implementation details that technical staff need to carry as quickly as possible or smoothly as possible, maybe, okay, without requiring the presence of the designer. All right. And also, you also have the appendices, which usually include lists and optionally configurations of existing network devices. So to summarize, using the top-down approach to network design. So designing an enterprise network is a complex project. Top-down design facilitates the process by dividing it into smaller and more manageable steps. Decision tables facilitate the selection of the most appropriate option from many possibilities. In assessing the network or the scope of network design, determine whether the design is for a new network or is a modification of the entire network, a single segment or module, a set of LANs, a WAN, or a remote access network. So the output of the design should be a model of the complete system. So to achieve this, the top-down approach is highly recommended. When the design is complete, you are ready to document the implementation and migration in as much detail as possible. So after a design is complete, you should verify it. You can test the design in an existing or live network pilot, or in a prototype network that will not affect the existing network. So a design document lists the design requirements, document the existing network, documents the network design, identifies the proof of concept strategy, and details an implementation plan. Now, to summarize the module, so the Cisco SONA is the enterprise framework for implementing intelligent networks and maps business requirements to network requirements. The design methodology under PPDIOO includes these tasks: identifying customer requirements, characterizing the existing network and sites, designing the network topology and solutions. The result of the network characterization is a summary report describing the health of the network. So top-down design facilitates network design. So we come to an end of this video lecture. See you on the next video.